Let us continue our journey to solve the MCQs of basic course in biomedical research. Coming to the 8th chapter, that is validity of epidemiological studies. Let us see the first question. Obtaining an estimate that is generalizable to the relevant study population in a research study is. They have asked generalizable to the relevant study population in a research study is what? The options are A. External validity, B. Internal validity, C. Bias, or D. Confounding. So the answer for this question is A. External validity, because it is a definition of external validity. See over here. These are the definitions of external validity and this is internal validity. You have to remember these two definitions. This is a question, this is also a question. Our present question is external validity. Let us see what it is written over here. To obtain an estimate that is generalizable to the relevant target populations. When they use this word generalizable to the relevant target populations, is external validity. Internal validity, let us see what it says. It says to obtain an accurate estimate of disease frequency and effect of exposure on health outcomes in the study population. So this is internal validity and this is external validity. Please remember these two definitions. Let us see the next question. Any process that tends to produce results that depart systematically from true values in a research study is called as what? The options are A. Chance, B. Bias, C. Random error, or D. Effect modification. So what is the answer for this question? C. Once again, any process that tends to produce results that depart systematically from true values in a research study is called as B. Bias. B. Bias is the answer for this question. See over here. This information given on this slide has to be kept in your minds. See bias over here. There are two types of errors. One is random error and one is systematic error. In bias, which is a part of systematic error, or it's also called as a process that tends to produce the results that depart systematically from true values. This is what is given in our question. Okay, so please remember this point. Let us see the next question. Systematic selection of more number of exposed participants with the higher risk of outcome in a cohort study will result in what? Options are A. Selection bias, B. Information bias, C is confounding, or D is random error. Once again, systematic selection of more number of exposed participants with the higher risk of outcome, exposure and outcome in a cohort study will result in what? So the answer for this question is, please remember this point, it is a selection bias. This is over here, selection bias will be resulting. Then next question. Let us see the next question. The effect of the exposure of interest on the outcome is distorted because of the effect of extraneous factors that are related to both the exposure and the outcome. So this phenomenon is called as what? Options are A. Correlation effect, B. Confounding, C. Recurrent bias, or D. Measurement error. Read the question carefully again. The effect of the exposure of interest on the outcome is distorted because of the effect of extraneous factors. This word extraneous factors that are related to both the exposure and the outcome. This phenomenon is called as B. Confounding. It is called as B. Confounding. See over here. This is the definition of confounding. The apparent effect of the exposure of interest is distorted because of the effect of extraneous factors is mistaken for or mixed with the actual exposure effect. This is what is called as confounding. Okay, so that was the answer for our question. You have to remember these points. See, whenever they use the words exposure of interest, please remember this word, because of the effect of extraneous factors. So you should think that they are speaking about the confounding. Let us see the next question. Biases can occur through which stage of the research study? The options are A. Study design, B. Study implementation, C. Data analysis, or D. At any of the above stages. So biases can occur during which stage they have asked. The answer for this question is that it can occur at any stage, at the level of study design, at the level of study implementation, or at the level of data analysis. At any level, biases can occur. Please remember this point. Next question. All are true regarding measures to reduce the information bias except. Now they are speaking regarding information bias. Okay. The options are A. Precise operational definitions of all the variables. B. Detailed measurement protocols. C is adequate sample size, or D is training, certification and recertification of the data collectors. So what are all the true? All are true except one statement. Let us see the options again. Precise operational definitions of all the variables. B is detailed measurement protocols. C is adequate sample size, or D is training, certification and recertification of the data collectors. So what is wrong? The answer for this question is C, adequate sample size, is wrong. Let us see over here. These are all the steps while you are dealing with the information bias. This has to be kept or imprinted in our minds. Okay, in our question they have asked precise operational definitions of all the variables. Yes, this was present in our question. Secondly, they have mentioned regarding detailed measurement protocols. Yes, even this was mentioned in the question, and it is also present in this list over here. Third thing was they have spoken regarding the adequate sample size. The adequate sample size is not listed in the steps in dealing with the information bias. So that was the answer for our question. See, the adequate sample size was not mentioned. Then last option, that is training, certification and recertification of data collectors. Training, certification and recertification of data collectors is also mentioned. So you have to keep in mind all these steps: 1, 2, 3, 4, 5, 6 and 7 steps in dealing with the information bias. Please remember this point. Let us see the next question. Variability in estimation due to unknown and uncontrollable factors is called as what? The options are A. Chance, B. Bias, C. Confounding, or D. Effect modification. The variability in estimation due to unknown or uncontrollable factors is called as A. Chance. Please remember this answer. Now see over here in this information, you will find the definition of variability. This was given in our question. Okay, variability is estimation due to unknown or uncontrollable factors. See over here, variability in estimation due to unknown or uncontrollable causes. You have further sampling error and measurement error underneath it. But this is the answer for our question. Variability in estimation due to unknown or uncontrollable factors is called as chance. It is called as chance. Please remember this point. It comes under random errors. So this is one question, this is one question, this is one question. These two were asked separately at other time questions. So this information given on this paper is supposed to be kept in our mind. Let us see the next question. All are true regarding confounding in an epidemiological study except. The options are A. It may simulate an association that does not exist. B. It may increase or decrease the strength of association. Or C. It may not reveal an association that does exist. Or D. It always changes the direction of effect. So all are true except one sentence. So the answer for this question is option number D, that is always changing the direction of effect is not true regarding confounding in an epidemiological study. See this information over here. This chart, this has to be kept in your mind. This is regarding confounding in epidemiological studies. In our question, let us see the statements. They have spoken. Let us see the first statement. Confounding may simulate an association that does not exist. See over here, it may simulate an association so that does not exist. So this is present and this is a correct statement. Let us see the second statement. It may increase or decrease the strength of association. It is given over here, increase or decrease the strength of association. So therefore even this statement is correct. Let us see the third statement. May not reveal an association that does exist. See, it may hide an association that does exist. So even this is present in our question. Let us see the last statement. Always change the direction of effect. It may change the direction of effect. It is not always. It is not always. Please remember this point, okay? It is not always. It is only that it may change the direction of an effect. So we got the answer for our question. Let us continue. The ninth question. The method which can used to alleviate the confounding during data analysis in an epidemiological study. The options are A. Multivariate analysis, B. Restriction, C. Matching, or D. Randomization. So what is the answer for this question? The answer is, it is A. Multivariate analysis. Now see the information given in this chart. They have asked regarding what was the method used to alleviate the confounding during data analysis. So this is the analysis stage, okay? Analysis stage, you have either stratification or multivariate analysis. Two steps to deal with the confounding in the analysis stage. So in the options we had multivariate analysis, therefore we have taken this answer. Let us see the other options. Restriction was mentioned, matching was mentioned, and randomization was also mentioned. So all these three come where? All these three come under design stage, not the analysis stage. So please read the question carefully and keep this chart in mind. If they ask options of the design stage, or if they mention as design stage in the question, then you have to select any of the options if they have mentioned over here, like restriction, matching, or randomization. But if they have mentioned, as in this question they have mentioned regarding the analytical stage, so and they have given multivariate analysis as the option, so we have taken this. The next question: to reduce selection bias in case control studies, all of the following are true except what? The options are A. Use population based design, B. Apply different eligibility criteria for selecting cases and controls, C. Both cases and controls undergo the same diagnostic procedures, or D. Avoid hospital based design. So to reduce the selection bias in a case control study, all of the following are true except what? So the answer for this question is applying of different eligibility criteria for selecting the cases and control. It is a wrong statement. Now see the information given over here and the options given in our question. So we have taken like apply different eligibility criteria for selecting cases and controls is a wrong statement. See the information over here. They have mentioned that in dealing with selection bias at the designing stage of the study, you apply same eligibility criteria for selecting of cases and controls, not a different. So this was the question what they have asked. Now let us see the other options. Use population based design, is it mentioned? Yes, it is mentioned, use population based design. Other option, both cases and controls undergo the same diagnostic procedures. Yes, both cases and controls undergo the same diagnostic procedures is mentioned over here. So this is mentioned, this is also mentioned, and this is mentioned with the variation. So therefore we have taken this answer. Next question: obtaining an accurate estimate of disease frequency and effect of exposure on health outcomes in study population pertains to what? Options are A. External validity, B. Internal validity, C is bias, or D is confounding assignment. Once again, let us see the question. Obtaining an accurate estimate of the disease frequency and effect of exposure on health outcomes in a study population pertains to what? So the answer for this question is B. Internal validity. We have already spoken regarding this. Please go to the first question of this chapter and please go through the question again and the discussion done over there. You will find that this is the definition of internal validity. Internal validity. Next question. Blinding in an epidemiological study is a way to deal with. Options are A. Chance, B. Selection bias, C. Information bias, or D is sampling error. So what is the answer for this question? Blinding in an epidemiological study is a way to deal with B. Selection bias. Please remember this answer. Next question. Better recall of exposure only among the cases in a case control study can result in what? The options they gave are A. Information bias, B is confounding, C is investigator bias, or D is selection bias. So the better recall of exposure only among the cases in a case control study can result in. Answer is A. Information bias. Now see the data or the information given in this chart. In our question they have spoken regarding the better recall of exposure only among the cases over here. See the statement given over here, recall. Okay, cases may recall exposure more than controls. In the question they have mentioned the better recall of exposure only among the cases. This statement was spoken in regards to the information bias. So this is the answer for this question. And please remember points from the information given in this chart, because there are many questions which can be asked from this chart. They have asked regarding prevarication ones, they have asked regarding the investigator ones, they have asked regarding the cohort studies and the information bias, they have asked regarding the case control studies and information bias. So many of the questions have been asked from this chart or the information given in this table. Next question. The ability of a tool to correctly measure what it is supposed to measure is called as what? The options are A. Precision, B. Validity, C. Reliability, or D. Consistency. So once again let us see the question. The ability of a tool to correctly measure what it is supposed to measure is called as. The answer is B. Validity. Please remember this definition. Okay. Next question. Bias may distort the association between exposure and outcome among the study participants. Is it a true statement or a false statement? Bias may distort the association between the exposure and the outcome among the study participants. So is it a true statement or a false statement? Answer is that it is a true statement. Please remember this point. It is a true statement. Next question. A case control study was conducted to know the effect of smoking on the lung cancer among hospitalized patients. The controls were recruited from patients admitted to the respiratory ward for other conditions. So what type of bias will be introduced by virtue of recruiting the controls from hospital itself who are potentially different from the general population? Okay, so what type of bias will be introduced by virtue of recruiting the controls they have taken from the hospital in spite of the general population? So what can happen? What are they doing? They are doing selection. So the options given over here are A. Selection bias, B. Information bias, C. Confounding, or D. Random error. So the answer for this question is A. Selection bias. Directly, it is very easy. From the question itself we can identify the answer. Next question. A researcher studied the effect of coffee drinking on MI. The effect of coffee drinking on MI was distorted because of the presence of a third factor. It is called as smoking, that is smoking. So this phenomenon is called as what? The options are A. Correlation effect, B. Confounding effect, C is recall bias, or D is measurement error. So the answer for this question is B. Confounding. Once again, if this question is asked in the examination, if they are speaking regarding the coffee drinking, MI, and the third factor as a smoking, and they give all these options of correlation effect, confounding, recall bias, or any other, if they mention confounding, then please select confounding as the answer. Next question. Which of the following method is used to address for known confounders at the designing stage of the study? The options they gave are A. Matching, B. Regression, C. Stratification, or D. Adjusted analysis. Once again let us see the question. Which of the following method is used to address for known confounders at the designing stage? Okay, at the designing stage of a study. The options they gave are matching, regression, stratification, and adjusted analysis. So the answer for this question is A. Matching. See the information given in this chart. This chart is supposed to be kept in your minds. Here we are dealing with confounding. Okay, there are two stages. One is the design stage and another one is the analysis stage. In our question they have asked which of the following method is used to address known confounders at the designing stage. In the designing stage, so in the designing stage we have restriction, we have matching, we have randomization, and in the options they gave matching, so therefore we have taken matching. Then regression, is it given in the designing stage? No, regression is not given in the designing stage. Stratification, is it given in the designing stage? No, stratification is a part in the analysis stage. So analysis and stratification, they have been given in the options separately, but it is not a part of the designing stage. So therefore, we have got the answer for our question, that is matching. Next question. Systematic distortion of the truth by study objectives or study subjects is called as what? Options are A. Plagiarism, B. Chance, C. is confounding, or D. is prevarication. What is systematic distortion of the truth by a study subject itself? So the answer for this question is D. Prevarication. Please remember the answer. It is a definition for prevarication. Now see this chart. We have previously discussed regarding this information given over here. See over here, prevarication. This was our question which was asked. Okay. It is systematic distortion of truth by the subjects. Systematic distortion of the truth by the subjects called as prevarication. Prevarication. Okay. So we got the answer for our question. Next question. Crude association in the presence of a confounder is actual causal association. Is it a true statement or a false statement? Crude association in the presence of a confounder. Is it the actual causal association? Is it a true or false statement? The answer is that it is a false statement. It is a false statement. Okay. Why? Let us see. Now, see this chart carefully. This is how you evaluate the associations in the form of a spiral way. You start from chance, then next comes the selection bias, then you go to the information bias, lastly you will come to the confounding. So, you will decide whether is it a true association or whether is it a causal association. So, two different types. So, the question what they have asked was, they have asked crude association in the presence of a confounder is the actual causal association. Is it correct or not? So it is not correct. In the presence, it is not only in the presence of confounding. It is from top to bottom, like chance, selection bias, information bias, and confounding. Not only confounding. Okay. So therefore, it is a false statement. Now let us see this question. Which of the following is the best method of ensuring that the experimental and control arms in an experimental study are similar with regard to known and unknown confounders at the planning stage? So what are the options? A. Matching, B. Randomization, C. Stratification, or D. Multivariate analysis. Let us see the question again. Which of the following is the best method, they are asking, of ensuring that the experimental and control arms in an experimental study are similar with regard to known and unknown confounders at the planning stage. So what is the answer for this question? The answer for this question is randomization. Please remember this question and also the answer. Okay. The best method of ensuring that the experimental and control arms in an experimental study are similar with regards to both known and unknown confounders at the planning stage. So it is randomization is the method. Okay. Next question. Which of the following is not a step in dealing with the information bias? Not a step. What are the options? Let us see the options. Options are A. Precise operational definitions of variables, B. Single measurement on key variables, C. Data cleaning, or D. Data audits. So which is not a step in dealing with the information bias? The answer for this question is B. Single measurement on key variables. How? Now let us once again see all the steps in dealing with information bias. I told you all to keep this chart in your minds. We will number all the steps 1, 2, 3, 4, 5, 6 and 7. Now in our question, let us see the options what were given in our question. Precise operational definitions of variables. Precise operational variables of definitions is given in the option or as a step in dealing with the information bias. Second, single measurement on key variables. I told that it is not a step. Let us see then what is the actual step. Detailed measurement protocols, repeated measurements on key variables. It is not single measurement, it is repeated measurements on key variables. Please remember this point. Okay, because they gave single measurement on key variables, we have told that this is not a step. Okay, then Let us see other two options, data cleaning and data audits. Are they available or not? See, data cleaning is present at the sixth step or the sixth point, data cleaning, and data audits at the fifth point. Okay, so all these things are dealing with the information bias. Please remember the answer. Let us see the next question. Which of the following can introduce selection bias in a case control study? The options are A. Differential recall about exposure by the cases. B. Collecting the data differently from the exposed and the unexposed. C. Inclusion of controls not representative of the target population. Or D. Systematic distortion of the truth by the study participants. So which of the following can introduce the selection bias in the case control study? Of the options given, the option number C, that is inclusion of controls not a representative of the target population. By doing so, you will introduce selection bias in the case control study. Please remember this point. Next question. Which of the following is true about information bias in a cohort study? The options are A. It is caused by higher attrition rate among the exposed group. Or B. It is caused by selecting controls from the community. Or C. It can be avoided by uniform outcome ascertainment. Or D. It can be minimized by reducing the loss to follow-up. So which of the following is true about the information bias in a cohort study? The answer for this question is option number C, that it can be avoided by uniform outcome assessment is true about information bias in a cohort study. Rest of the statements are false statements when pertaining to information bias in the cohort study. Please remember the answer for this question. Next question. Which of the following is not a systematic error in an epidemiological study? The options are A. Random error, B. Confounding, C. Selection bias, or D. Information bias. It is a very simple question. The answer for this question is A. Random error. Random error is not a systematic error because all the others are systematic errors. All the others are systematic errors. You have selection bias, information bias, and confounding all come under bias. So they are grouped under systematic errors. Random error is a different entity. Next question. Which of the following measure is related to ensuring the internal validity of a study? The options are A. Using a validated study questionnaire to assess the outcomes. B. Including an adequate number of study participants. C. Complying strictly with the study protocols, or D. All of the above. So which of the following measure is related to ensuring the internal validity of a study? Let us see the options given again. Using a validated study questionnaire to assess the outcomes. Yes, this is a correct statement. Then including an adequate number of study participants. Yes, even this is correct measure. Third thing, complying strictly with the study protocols. Yes, even this is a correct statement. So therefore, all the above are correct options given for this particular question. Please remember, please read the question again and the options again and again. Next question. Which of the following is false about confounding in the epidemiological studies? Let us see the statements. Option number A. Confounding may simulate an association when it does not exist. B. Confounding does not increase or decrease the strength of the association. C. Confounding may hide an association that exists. Or D. Confounding may change the direction of an exposure outcome association. So which is false? The answer for this question is B, that is confounding does not increase or decrease the strength of the association is a false statement about confounding in epidemiological studies. Now see this chart. We have spoken regarding this chart previously also. We will repeat again regarding confounding in epidemiological studies. See in our question what they have asked. They have asked regarding the false statement. Let us see the other statements one by one. Statement number 1. Confounding may simulate an association when it does not exist. So confounding may simulate an association that does not exist. It is given in the question and it was a correct statement. Let us see the second statement. Confounding does not increase or decrease the strength of the association. They mentioned over here. But actually confounding may increase or decrease the strength of the association. Okay. So this was mentioned in a wrong way. So we have taken that answer. Third step or the third option. Confounding may hide an association that exists. Yes, confounding may hide an association that exists is also given over here. And the fourth option, that is confounding may change the direction of an exposure outcome association. Yes, even this is mentioned over here, that confounding may change the direction of an effect. Okay, so please remember this chart. Next question. Systematic collection of data by an investigator supporting an expected conclusion in an epidemiological study may result in what? The options are A. Confounding, B. Information bias, C is selection bias, or D is random error. Once again, let us see the question. Systematic collection of data by an investigator supporting an expected conclusion in an epidemiological study may result in B. Information bias. See this chart. We have previously spoken regarding this chart. I told that this may be asked as a question. The investigator. Systematic collection of information strongly expected conclusions is, and it comes under information bias in the epidemiological studies. This is what they have asked in our question. Next question. Which of the following is not a method of dealing with confounding during the design stage? The options are A. Restriction, B. Stratification, C. Matching, and D. Randomization. This question is asked again and again and again. We have seen that there are two stages: design stage and analytical stage. Okay, so in our question they have asked which of the following is not a method. So in the analytical stage you have stratification and multivariate analysis Okay, in the design stage you will have your restriction, you will have matching, and then you will have randomization. We have discussed this previously also. So the answer for this question is stratification. Which of the following is not a method? Stratification is not a method of dealing with confounding during the design stage. Please remember this point. Okay, whenever you are dealing with the confounding. Okay, chalo. Next question then. A cohort study was conducted to examine the association between obesity and cardiovascular disease. Okay, so during analysis, gender was suspected to be a confounder. So which of the following methods will help in examining the confounding effect due to gender? Options are A. Matching, B. Restriction, C. Randomization, or D. Multivariate regression. Cohort study was conducted to examine the association between obesity, cardiovascular disease, and then during analysis, gender during analysis. Okay, so we got the answer from our question. Analytical stage and confounding. Just now we have seen in the previous question itself. Analytical stage, you have two things: design stage, analytical stage. Analytical, you have stratification and multivariate regression. So the answer for this question is option number D. Okay, next question. Which of the following is not a step in dealing with information bias? The options are A. Precise operational definitions of variables, B. Repeated measurements on key variables, C is data cleaning, or D is rerunning of all the analysis after the publication. So which is not a step in dealing with information bias? Please go back to previous questions. We have discussed regarding all the steps. There are around 7 steps in the. So the answer for this question is option number D, that is rerunning of all the analysis after the publication. Let us see all the other statements. Precise operational definitions of variables. Yes, this is a statement or this is a step in dealing with the information bias. Second is repeated measurements of key variables. Yes, even this is present. Third is data cleaning. Yes, even this was present. Fourth one, the rerunning of all the analysis after the publication is not present because rerunning of all the analysis should be done before the publication, not after the publication. Okay, before the publication. Please remember the answer. Next question. State whether true or false. It is necessary to make sure that diagnosis of a disease is not affected by the exposure status, that is blinding, in dealing with selection bias during the stage of data collection. Is it a true statement or a false statement? During the stage of data collection. Well, let us see the question again. It is necessary to make sure the diagnosis of the disease is not affected by exposure status in dealing with the selection bias during the stage of data collection. Yes, this is definitely a true statement. Next question. Threats to avoid in epidemiological studies. What are the threats? The options are A. Selection bias, B. Information bias, C. Confounding, or D. All of the above. This is a very simple question. Answer is all of the above. Okay, see the threats to validity in epidemiological, you have selection bias, you have information bias, you have confounding. All these are systematic errors. Okay, so next question. 34. Detailed measurement protocols are not required in dealing with the information bias. Is it a true statement or a false statement? Definitely it is a false statement. Please remember all the steps what we mentioned. 1, 2, 3, 4, 5, 6, 7 we mentioned. Okay, we have discussed this previously. So detailed measurement protocols are required in dealing with information bias actually, but because they have mentioned it as not required, so therefore it is a false statement. Next question. Which bias is related to differences in how information is recalled by participants? Options are A. Observer bias, B. Selection bias, C. Recall bias, or D. Information bias. Once again, which bias is related to differences in how the information is recalled by participants? So the answer itself is given in the question. So this is the recall bias. Next question. Which is wrong pertaining to dealing with the selection bias? The options are A. Use the same eligibility criteria for cases and control selection, B. Use the incident cases, C. Use the prevalent cases, or D. Use the population based design. So which is wrong pertaining to dealing with selection bias? We'll see the options again. You use the same eligibility criteria for cases and controls. Yes, this is the correct statement. You use incidental cases. Yes, this is the current case. This is correct statement. You use prevalent cases. No, you do not use prevalent cases. No prevalence. Okay, so this is the wrong statement. So this is the answer for this question. Then the last option, use population based design. Yes, this is also correct statement. Next question. What is cohort study? Let us see the options. Collection of information supporting the expected conclusion. B. Collection of information leaning towards a specific outcome. Or C. Systematic distortion by subjects. Or D. Collection of studies. We have studied previously. What is cohort study? Cohort study is that which comes from exposure to outcome. Okay, so the answer for this question is collection of information leaning towards the specific outcome. This is cohort study. Next question. What is case control study? Options are A. Collection of information leaning towards specific exposure, or B. Collection of studies, or C. Systematic or systemic distortion by studies, or D. Collection of information supporting the expected conclusion. So what is case control study? Previously it is from outcomes to exposure. Exposure to outcome is cohort study. Okay, outcome to exposure is case control study. Okay, please remember this point. So the answer for this question is option number A. Next question. In which study design is the risk of confounding particularly high? High confounding. Okay, the options are A. Randomized control trial, B. Cross-sectional study, C is case control study, or D is cohort study. So in which study design is the risk of confounding particularly high? The answer is C. Case control study. In case control study, confounding will be high. Then next question. Bias can occur in all the epidemiological studies. Is it a true statement or a false statement? Yes, it is definitely a true statement. Bias can occur in all the epidemiological studies. Yes, it is a true statement. Next question. What is the common method to control the confounding in a study design? How do you control confounding? Options are A. Randomization, B. Blinding, C. Placebo use, or D. Matching. Common method to control confounding in a study design is D. Matching. By matching you can control the confounding. If you remember, we spoke regarding dealing with confounding. Okay, In that we have spoken regarding two things: design stage and analytical stage. Go back to previous questions and see. Okay, but in designing stage we have spoken regarding three options. One was matching, second is randomization, and third was restriction. So from the options given, we have both randomization, we have both matching in the study design. Okay, in the design. So the question was, what is the common method? So of the two methods of matching or randomization, if both are given as options, please select matching as the answer. So we have taken matching as the answer. Please remember, this is a very confusing question because two options were given from the design stage of dealing with confoundings. Next question. A researcher measures the blood pressure using a sphygmomanometer on 3 different occasions. The values were found to be close to one another. What is the term used to denote this phenomenon? The options are A. Reliable, B. Valid, C. Precision, or D. Accurate. So what is the answer for this question? The values are found to be close to one another. So the answer is C. Precision. See this diagram and try to keep this picture in mind. See, in our question they have asked the values were found to be close to one another, and I have put a diagram over here, close to one another, and we have taken as precision. See this picture over here. In the first part or in the first column, if it is precise, then all the variables or all the values are near close to each other. In the second also, this is the first picture, this is the second picture. If you take the second picture into consideration, all the values are close to each other. So therefore they are precise. They are precise. Okay. And in the remaining two, if you consider this as 3 and this as 4 of the bullseye, if all the values are discrete or not close to each other, then they are not precise. Then they are not precise. Okay. Please remember this point. Then how will you say it is valid or invalid? If all the points or all the shots, if they are close to each other and near the internal circle, then they are valid. Then they are valid. Okay. If any point, if it is in the inner circle, even then it is valid. So therefore 1 and 3 are valid. But because the inner circles are not at all involved, therefore they are not valid in figure number 2 and 4. Okay. So this is they may give you a picture and they may ask what is precise and what is valid, or what is precise and what is not valid. Of the 4 permutations and combinations, they may ask you anything. But coming to our question, the values were found to be close to one another. So therefore this term is used to denote the phenomenon. It is called as precision. Okay. Next question. The estimates that researchers produce are based on samples, and samples may not accurately reflect what is really going on in the population. So which of the following threats to the validity does it results in? The options are A. Random error, B. Systematic error, C. Confounding, or D. Effect modification. The estimates that researchers produced based on the samples, and samples may not accurately reflect what is really going on in the population. So what the threat happen? It will happen in random error. Okay, please remember this point, because confounding and systematic error both are related to each other. Okay, so we have deleted easily. Effect modification is opposite of confounding, so even this is not related. Therefore the answer for this question you can take in this way as random error. Next question. A researcher planned a prospective study, okay, on healthy eating habits among the adolescents. If the people who have healthy lifestyles and healthy behaviors were more likely to participate in the study due to the proposed study method, what bias is likely to occur? The options are A. Information bias, B is selection bias, C is measurement bias, and D is confounding bias. Once again we will see the question. A researcher planned a prospective study on a healthy eating habits among adolescents. If the people who have healthy lifestyles and healthy behaviors were more likely to participate in the study, due to the proposed study method, what bias is likely to occur? So you will be selecting healthy lifestyle people with healthy behaviors people. So you are selecting, but still bias will occur. So this is a selection bias. Please remember this point. Okay, this is how you have to answer this question. Next, missing data can result in which of the following? Options are A, selection bias, B, loss to follow-up bias, C is information bias, or D is volunteer bias. The answer is very simple. The answer is C, information bias. Missing data can result in the information bias. Next question. What is the term used to denote association between exposure and outcome among the study participants differs from causal association in the population? What is the term used to denote the association between exposure and outcome among the study participants which differs from the causal association in the population? The options are A, errors in estimation, B, effect modification, C, precision, or D, causal association. The answer for this question is A, errors in estimation. See this chart again. Errors in estimation is the question what it has asked. So the association between exposure and outcome among the study participants differs from the causal association in the population. Okay, so we got the answer for our question. Next question. Which bias occurs when participants or researchers are aware of the exposure status? Which bias occurs when participants or researchers are aware of the exposure status? Is it A, selection bias, B, observer bias, C, recall bias, or D, measurement bias? So the answer for this question is B, observer bias. Observer bias occurs when both, because participants are also, they know, and even researchers are aware of the exposure status. So definitely they will be having observer bias. Next question. Which of the following is a method to deal with the information bias? Options are A, repeated measurements on key variables, B, minimize non-response, C, comparison of the baseline variables, or D, sensitivity analysis. Which of the following is a method to deal with information bias? We have already discussed this in detail. There were around 7 steps. So among this and among the options given over here, the answer is A, that is repeated measurements on key variables is a method to deal with information bias. Please go to the previous questions and you follow for the information bias, you will get the answer over there. Next question. Which of the following is a method to deal with selection bias? Now they have asked regarding the selection bias. The options are A, precise operation definition of variables, B, detailed measurement protocols, C, training the data collectors, or D, apply the same eligibility criteria across the groups. So which is the method to deal with the selection bias? The answer for this question is D, apply the same eligibility criteria across the groups is a method to deal with the selection bias. We have seen this previously. Okay. Now let us see the last question. A researcher wanted to know if treating index osteoporotic vertebral fractures with vertebroplasty increased the risk of subsequent vertebral fractures. So a total of 500 patients were included, of whom 250 underwent vertebroplasty while the remaining underwent the conventional standard of care. The study population was stratified to check whether the significant association found in the study was true or not. So on comparison, the participants had similar age and gender characteristics. The researchers conducted a stratified analysis based on smoking. The estimate was same in both the groups. What does this indicate? The options are A, effect modification, B, interaction, C, confounding, or D, random error. Such a long question, but they have given a clue. The clue is over here. The researchers conducted a stratified analysis based on smoking. Okay, so what does this indicate? It is a way of dealing with confounding. Last time, again, I will tell you again. See, dealing with confounding has two types or two stages: analytical stage and design stage. Many times, many questions have been asked on this concept itself. Okay, so in analytical, you have stratification. and secondly you have multivariate analysis. Okay, so in the question the researchers conducted a stratified analysis. They themselves gave a clue. So this was in dealing with confounding. So therefore we took confounding as the answer for this question. So with this we complete chapter number 8. Now let us quickly go to chapter number 9. Thank you.